client-server network. In this video, we are going to learn about client-server network. The term client-server refers to the concept of sharing the work involved in processing data between the client computer and the most powerful server computer. A server is a computer running a process that provides a service to other computers when they request it. A client is a computer running a program that requests the service from the server. Client-server networks are more suitable for larger networks. A central computer or server acts as the storage location for files and applications shared on the network. The server also controls the network access of the other computers, which are referred to as the client computers. For example, a LAN-based database application stores its data on a server which stands by waiting for clients to request information from it. Users of workstation computers run a database client program in which they generate queries that request specific information in the database and transmit those queries to the server. The server responds to the queries with the requested information and transmits it to the workstations, which format it for display to the users. They are also responsible for taking the raw data from the server and displaying it in a comprehensible form to user. Advantages of client-server: all files are stored in a central location. Backups and network security is controlled. Users can easily access to the shared data. Disadvantages of client-server: a special network operating system is needed. The server is expensive to purchase and difficult to set up initially. If one of the server goes down, all the users get affected and it may even bring the whole network down. Network File System, that is NFS. In this video, we are going to see about Network File System, that is NFS. Network File System. Network File System, that is NFS, is a distributed file system, that is DFS, developed by Sun Microsystems. This allows directory structures to be spread over the networked computing systems. A DFS is a file system whose clients, servers, and storage devices are dispersed among the machines of distributed system. NFS follows the directory structure almost same as that in non-NFS system, but there are some differences between them with respect to naming, path names, semantics. Naming. Naming is a mapping between logical and physical objects. For example, users refers to a file by a textual name, but it is mapped to disk blocks. There are two notions regarding name mapping used in DFS: location transparency, location independence. A location-independent naming scheme is basically a dynamic mapping. NFS does not support location independency. Mounting. The mount protocol is used to establish the initial logical connection between a server and a client. A mount operation includes the name of the remote directory to be mounted and the name of the server machine storing it. The server maintains an export list which specifies the local file system that it exports for mounting along with the permitted machine names. Mount can be of three types: soft mount, hard mount, auto mount. NFS protocol and remote operations. The NFS protocol provides a set of RPCs for remote operations like lookup, create, rename, get attribute, set attribute, read, write, remove, make directory, etc. NFS servers are stateless servers. A stateless file server avoids to keep state informations by making each request self-contained. That is, each request identifies the file and the position of the file in full, so the server need not to store the file pointer. Moreover, it need not establish or terminate a connection by opening a file or closing a file respectively. For reading a directory, NFS does not use any file pointer. It uses a magic cookie. Except the opening and closing a file, there is almost one-to-one mapping between Unix system calls for file operations and the NFS protocol RPCs. A remote file operation can be translated directly to the corresponding RPC. Since NFS runs on RPC and RPC runs on UDP/IP, which is unreliable, operation should be idempotent. Telnet. In this video, we are going to see about Telnet. It is an internet service that allows the user logs on and runs on a remote computer and use programs installed on the remote computer. Telnet is a terminal emulation that enables a user to connect to a remote host or device using a Telnet client. The term Telnet may also refer to the software that implements the client part of the protocol. Telnet client applications are available for virtually all computer platforms such as Windows 95, 98, NT, 2000, Linux, Unix, etc. Telnet enables a user to manage an account or device remotely. For example, a user may telnet into a computer that hosts their website to manage his or her files remotely. Telnet is a client-server protocol based on a reliable connection-oriented transport. Typically, this protocol is used to establish a connection to Transmission Control Protocol, that is TCP, port number 23. Telnet is considered insecure because it transfers all data in clear text. which means if a user was sniffing a network, it is very possible they could grab your username and password as they were being transmitted. Most implementations of Telnet have no authentication that would ensure communication is carried out between the two desired hosts and not intercepted in the middle. Several vulnerabilities have been discovered over the years in commonly used Telnet daemons. These security-related shortcomings have seen the usage of the Telnet protocol drop rapidly, especially on the public internet, in favor of the Secure Shell Protocol, that is SSH, first released in 1995. Users who are concerned about the data being transmitted should consider SSH as opposed to Telnet. SSH provides much of the functionality of Telnet with the addition of strong encryption to prevent sensitive data such as passwords from being intercepted and public key authentication to ensure that the remote computer is actually who it claims to be. Telnet commands. Now let us see the Telnet commands. Telnet. To start Telnet client and to enter the Telnet prompt, at the Telnet prompt, Telnet commands must be used. Telnet / remote server. Remote server specifies the name of the server to which you want to connect. To stop Telnet client, quit. User can abbreviate this command to Q. To connect Telnet client to a remote computer, open / remote server port. Port specifies the port that is needed to be used. If port is not specified, the default port is assumed. User can abbreviate this command to O. To disconnect Telnet client from a remote computer, close / remote server. / remote server specifies the name of the server that is needed to be managed. If server is not specified, then local server is assumed. User can abbreviate this command to C. To send Telnet client commands, send / remote server AO AYT escape IP sing ? / remote server specifies the name of the server that is needed to be managed. If server is not specified, then local server is assumed. AO aborts output command. AYT sends an "Are you there?" command. ESC sends the current escape character. IP interrupts the process command. Sync performs the Telnet sync operation. A question mark allows you to view the complete syntax for this command. To view the current settings for the Telnet client, display. The display command lists the currently operating parameters for the Telnet client. To administer Telnet sessions, Telnet admin / remote server -s -k session id all -m session id all message / remote server specifies the name of the server that is needed to be managed. If server is not specified, then local server is assumed. -s displays active Telnet sessions. -k session id all terminates sessions. Type the session id to terminate a specific session or type all to terminate all sessions. -m session ID all message sends a message to one or more sessions. Type the session ID to send a message to a specific session, or type all to send a message to all sessions. Type the message that you want to send between quotation marks, that is, message. To set the Telnet port on a computer running Telnet server. Telnet admin / remote server config port is equal to integer value. / remote server specifies the name of the server that is needed to be managed. If server is not specified, then local server is assumed. Port is equal to integer value sets the Telnet port. You must specify the port with an integer smaller than 1024. To set the mode of operation on a computer running Telnet server. Telnet admin / remote server config mode is equal to console or stream. / remote server specifies the name of the server that is needed to be managed. If server is not specified, then local server is assumed. Mode is equal to console or stream specifies the mode of operation. File Transfer Protocol (FTP). Now we are going to see about File Transfer Protocol (FTP). File Transfer Protocol (FTP) is a standard network protocol used to transfer files from one host to another host over a TCP-based network such as the Internet. FTP is built on a client-server architecture and uses separate control and data connections between the client and the server. FTP users may authenticate themselves using a clear text sign-in protocol, but can connect anonymously if the server is configured to allow it. Before the World Wide Web, the FTP was the only way to transfer large files between computers of Internet users. The first FTP client applications were interactive command line tools implementing standard commands and syntax. Graphical user interface clients have since been developed for many of the popular desktop operating systems in use today. The FTP protocol can handle text files with ASCII or ABCDIC character sets. The first FTP client applications were command line applications developed before operating systems had graphical user interfaces and are still shipped with most Windows, Unix, and Linux operating systems. FTP is most commonly used to download a file from a server using the internet or to upload a file to a server. FTP works in the same way as HTTP for transferring web pages from a server to a user's browser, and SMTP for transferring electronic mail across the internet, in that, like these technologies, FTP uses the internet's TCP/IP protocols to enable data transfer. FTP package provides all the tools needed to look at files and directories, change to other directories, and transfer files from one system to another system. FTP uses TCP to actually move the files. An FTP server authenticates the user via a simple username and plaintext password. Some FTP servers also allow anonymous logins without passwords. There is an RFC for security enhancements to FTP that is not widely deployed. because FTP relies on TCP when transferring data, error recovery and flow control is built in. Trivial file transfer protocol. Now we are going to see about trivial file transfer protocol. Trivial file transfer protocol. It is primarily used to boot diskless workstations and to transfer boot images to and from routers. It is generally used for automated transfer of configuration or boot files between machines in a local environment. It uses a reduced feature set. In addition to its reduced size, it also uses UDP instead of TCP, which makes for faster transfers but with no reliability. In TFTP, the client initiates the communication by issuing a request to the server. Then if the server grants the request, then the connection is opened and file is sent in 512 bytes fixed blocks. Secure file transfer protocol. It is used to transfer the file over an encrypted connection. SFTP clients are functionally similar to FTP clients, but they use different protocols. SSH session is used to encrypt the connection and then the file is transferred using SFTP protocol. It is mainly used to transfer files between computers. SMTP, Simple Mail Transfer Protocol. Now we are going to see about SMTP, that is Simple Mail Transfer Protocol. Email system. Email system protocols are the languages and rules that email servers and clients use to communicate with each other and manage incoming and outgoing mails. These protocols are strictly defined and are in use in a variety of different email clients. In addition, each email protocol has a unique way of managing email that is sent and received from an email account. Email protocol. Email protocols are the languages and rules that email servers and clients use to communicate with each other and manage incoming and outgoing mail. These protocols are strictly defined and are in use in a variety of different email clients. In addition, each email protocol has a unique way of managing email that is sent and received from an email account. SMTP, Simple Mail Transfer Protocol. SMTP stands for Simple Mail Transfer Protocol. It is a set of communication guidelines that allow software to transmit email over the internet. Most email software is designed to use SMTP for communication purposes when sending email, and it only works for outgoing messages. When people set up their email programs, they will typically have to give the address of their internet service provider's SMTP server for outgoing mail. There are two other protocols, POP3 and IMAP, that are used for retrieving and storing email. SMTP provides a set of codes that simplify the communication of email messages between servers. It's a kind of shorthand that allows a server to break up different parts of a message into categories the other server can understand. Any email message has a sender, a recipient, or sometimes multiple recipients, a message body, and usually a title heading. From the perspective of users, when they write an email message, they see the slick interface of their email software, but once that message goes out on the internet, everything is turned into strings of text. This text is separated by code words or numbers that identify the purpose of each section. The other purposes of SMTP is to set up communication rules between servers. For example, servers have a way of identifying themselves and announcing what kind of communication they are trying to perform. There are also ways to handle errors, including common things like incorrect email addresses. SMTP was created in the early 1980s and it was built around basic concepts of server communication that go back to the 1970s. In those days, the internet was a very closed community, mostly consisting of scientists and government institutions. The greatest strengths of SMTP are reliability and simplicity. It is easy to set up software that uses the SMTP communication rules and it gets the job done. Messages either get to a recipient or there is an error message that explains why that was not possible. Nowadays, most servers or slightly updated version of the SMTP protocol called ESMTP, that is Extended Simple Mail Transfer Protocol. This was created to allow transmission of multimedia through email. When someone sends a picture or music file through their email program, ESMTP communication codes are used to identify the kind of data being transferred. Post Office Protocol 3, that is POP3. In this video, we are going to see about Post Office Protocol 3, that is POP3. POP3, Post Office Protocol 3, is the most recent version of a standard protocol for receiving email. POP3 is a client-server protocol in which email is received and held for you by your internet server. POP3 is designed to delete mail on the server as soon as the user has downloaded it. However, some implementations allow users or an administrator to specify that mail be saved for some period of time. POP3 functionality. POP3 has become increasingly sophisticated so that some administrators can configure the protocol to store email on the server for a certain period of time, which would allow an individual to download it as many times as they wished within that given time frame. While mail servers can use alternate protocol retrieval programs such as IMAP, POP3 is extremely common among most mail servers because of its simplicity and high rate of success. Although the newer version of POP offers more features at its basic level, POP3 is preferred because it does the job within a minimum of errors. POP3 is a basic method of storing and retrieving mail. It can work with virtually any email program as long as the email program is configured to host the protocol. Many popular email programs including Eudora and Microsoft Outlook are automatically designed to work with POP3. Each POP3 mail server has a different address which is usually provided to an individual by their web hosting company. World Wide Web WWW. In this video, we are going to see about World Wide Web WWW. Introduction to World Wide Web, that is WWW. World Wide Web, abbreviated as WWW or W3, commonly known as the web, is a system of interlinked documents that are accessed via the Internet. The term Internet and WWW are often used in everyday speech without much distinction. In 1989, a small group of people led by Tim Berners-Lee at CERN, that is Conseil Européen pour la Recherche Nucléaire, or the European Laboratory for Particle Physics, proposed a new protocol for the Internet as well as a system of document access to use it. The intent of this new system, which the group named the World Wide Web, was to allow scientists around the world to use the Internet to exchange documents describing their work. Web or Internet. It is important to understand that the Internet and the World Wide Web are not the same thing. The Internet is a collection of computers and other devices connected by an equipment that allows them to communicate with each other. The web is a collection of software and protocols that has been installed on most, if not all, of the computers on the Internet. The Internet was quite useful before the web was developed, and it is still useful without it. Web is a collection of interconnected documents and other resources linked by hyperlinks and URLs. Thus, in short, the web is an application running on the Internet. Viewing a web page begins either by typing the URL of the page into a web browser or by following hyperlinks to that page. World Wide Web WWW. With a web browser, one can view web pages that may contain text, images, videos and other multimedia and navigate between them via hyperlinks. Provide a graphical interface. Allow you to create links from one piece of information to another. Can incorporate references to text, graphics, sound and movies or multimedia. The World Wide Web is non-linear with no header and footer. The meaning of non-linear is users do not have to follow a hierarchical path to information resources. The web is based on a client-server system. We use a web client to communicate with a web server. A web server is a computer connected to the Internet that runs a program which is also called web server that takes responsibility for sorting, retrieving, and distributing some of the web files. A web client or web browser is a computer that requests files from the web. An URL specifies the protocol to be used in accessing the resource, the name of the server on which the resource resides, and optionally the path to a resource. For example, http://www.nielit.in. Hypertext Transfer Protocol is the standard protocol that allows web clients and servers to communicate. This protocol is used to carry requests from a browser to a web server and to transport pages from the web server back to the requesting browser. The hypertext markup language is the universal language of the web. It is used for writing pages for the web. HTML allows text to include codes that define fonts, layout, embedded graphics, and hypertext links. HTML can be compared to word processing. User can tune into web radio and TV broadcasts and listen to live broadcasts or call up older ones from the archives. Domain Name System (DNS). Now we are going to see about Domain Name System (DNS) in this video. The Domain Name System (DNS) was originally invented to support the growth of email communications on the ARPANET and now supports the Internet on a global scale. The DNS as a whole consists of a network of servers that maps Internet domain names like www.livinginternet.com to a local IP addresses. The DNS enables domain names to stay constant while the underlying network topology and IP addresses change. This provides stability at the application level while enabling network applications to find and communicate with each other using the Internet protocol, no matter how the underlying physical network changes. DNS uses a client-server network architecture. The domain name system (DNS) servers distribute the job of mapping domain names to IP addresses among servers allocated to each domain. Domain name and their organization. Now let us see the process of domain name and their organization. Internet domain names are the alphanumeric identifiers people use to refer to hosts on the Internet like livinginternet.com. The structure of Internet domain names was first described in RFC 819 and their syntax was first described in RFC 822. Domain names come in four main types as follows: top-level domains, second-level domains, third-level domains, country domains. Top-level domains. Internet domain names are organized by their levels, with the higher levels on the right. Every domain name ends with a top-level domain label. For example, for the domain www.20.net, the top-level domain is net. Some of the top-level domains are .gov for government sites, .edu for educational institutions, .org for organizations that is non-profit, .mil for military sites, .com for commercial business, .net for network organizations. Second-level domains. Top-level Internet domains like .com are shared by all the organizations in the domain. Second-level domain names like yahoo.com and livinginternet.com are registered by individuals and organizations. Second-level domains are the addresses commonly used to host Internet applications like hosting and email addressing. Excluding the top-level domain portion, second-level domain names can have up to 61 characters. For many years, characters were restricted to the 26 letters, 10 numbers, or the hyphen character, except the hyphen can't be the first or last character. Third-level domains. Third-level domain names are created by those that own second-level domains. Third-level domains can be used to set up individual domains for specific purposes, such as a domain for web access and one for mail, or a separate site for a special purpose like www.livinginternet.com, mail.livinginternet.com, rareorchids.livinginternet.com. Fourth level and even higher internet domains like www.2.un.news.media.20.net can also be established. 3 of these 4 levels is usually sufficient for most purposes. Country domains. Each country in the world has its own top-level internet domain with a unique alphabetic designation. A few country domains are shown below. .in for India, .au for Australia, .ca for Canada, .us for United States. DNS servers. In this video, we are going to see about DNS servers. When a resolver has a query about a domain name, it passes the query to one of the local name servers. If the domain is remote and no information about the requested domain is available locally, the name server sends a query message to the top-level name server for the domain requested. The 8 steps for resolving the remote name. Steps. It sends a query to the local name server cs.vu.nl. This query contains the domain name, sort, the type that is A, and the class that is IN. Suppose the local name server has never had a query for this domain before and knows nothing about it. It may ask a few other nearby name servers, but if none of them know, it sends a UDP packet to the server for edu given in its database eduserver.net. This server knows all its children, so it forwards the request to the name server for yale.edu. This forwards the request to cs.yale.edu, which must have the authoritative resource records. Step 5 to 8. Each request is from a client to a server. The resource records the requested works in its way back in these steps. HTTP. In this video, we are going to learn about HTTP. The Hypertext Transfer Protocol (HTTP) is an application-level protocol for distributed collaborative hypermedia information systems. This is the foundation for data communication for the World Wide Web, that is Internet, since 1990. HTTP is a generic and stateless protocol which can be used for other purposes as well, using extension of its request methods, error codes, and headers. Basically, HTTP is a TCP/IP based communication protocol which is used to deliver data, that is HTML files, image files, query results, etc. on the World Wide Web. The default port is TCP/80, but other ports can be used. It provides a standardized way for computers to communicate with each other. HTTP specification specifies how clients' request data will be constructed and sent to the server, and how servers respond to these requests. Basic features of HTTP. There are following three basic features which makes HTTP a simple but powerful protocol. HTTP is connectionless. The HTTP client, that is browser, initiates an HTTP request, and after a request is made, the client disconnects from the server and waits for a response. The server processes the request and re-establishes a connection with the client to send response back. HTTP is media independent. This means any type of data can be sent by HTTP as long as both the client and server know how to handle the data content. This is required for client as well as server to specify the content type using appropriate MIME type. HTTP is stateless. As mentioned above, HTTP is a connectionless, and this is a direct result that HTTP is a stateless protocol. The server and client are aware of each other only during a current request. Afterwards, both of them forget about each other. Due to this nature of the protocol, neither the client nor the browser can retain information between different requests across the web pages. HTTP architecture. The HTTP protocol is a request-response protocol based on client-server based architecture where web browser, robots, and search engines, etc. act like HTTP clients and web server acts as server. Client. The HTTP client sends a request to the server in the form of a request method, URI, and protocol version followed by a MIME like message containing request modifiers, client information, and possible body content over a TCP/IP connection. Server. The HTTP server responds with a status line including the message protocol version and its success or error code, followed by a MIME like message containing server information, entity meta information, and possible entity body content. HTTP version. HTTP uses a minor numbering scheme to indicate versions of the protocol. The version of an HTTP message is indicated by an HTTP version field in the first line. Here is the general syntax of specifying HTTP version number. Example: Uniform Resource Identifiers URI. Uniform Resource Identifiers URI is simply formatted, case-insensitive string containing name, location, etc. to identify a resource, for example a website, a web service, etc. A general syntax of URI used for HTTP is as follows. Here, if the port is empty or not given, port 80 is assumed for HTTP and an empty ABS underscore path is equivalent to an ABS underscore path of /. The characters other than those in the reserved and unsaved sets are equivalent to their percentage hex encoding. Date time formats. All HTTP date timestamps must be represented in Greenwich Mean Time, that is GMT, without exception. HTTP applications are allowed to use any of the following three representations of date timestamps. Character sets, user use character set to specify the character sets that the client prefers. Multiple character sets can be listed separated by commas. If a value is not specified, the default is US ASCII. Example: following are valid character sets. Content encodings. A content encoding values indicate an encoding algorithm has been used to encode the content before passing it over the network. Content codings are primarily used to allow a document to be compressed or otherwise usefully transformed without losing the identity. All content coding values are case insensitive. HTTP 1.1 uses content coding values in the accept encoding and content encoding header fields. Example: following are valid encoding schemes. Media types. HTTP uses Internet media types in the content type and accept header fields in order to provide open and extensible data typing and type negotiation. All the media type values are registered with the Internet Assigned Number Authority (IANA). Following is a general syntax to specify media type. The type, subtype, and parameter attribute names are case insensitive. Example: language tags. HTTP uses language tags within the accept language and content language fields. A language tag is composed of one or more parts, a primary language tag and a possibly empty series of subtags. Whitespace is not allowed within the tag and all tags are case insensitive. Example tags include HTTP request header. The information in the form of a text record that a user's browser sends to a web server containing the details of what the browser wants and will accept back from the server. The request header also contains the type, version, and capabilities of the browser that is making the request so that server returns compatible data. Upon receipt of the request header, the server will return an HTTP response header to the client that is attached to the files being sent. HTTP response header. The information in the form of a text record that a web server sends back to the client's browser in response to receiving an HTTP request. The response header contains the date, size, and type of file that the server is sending back to the client and also data about the server itself. The header is attached to the files being sent back to the client. Hypertext Markup Language HTML. In this video, we are going to see about Hypertext Markup Language HTML. HTML stands for Hypertext Markup Language. It is a language for describing web pages. A markup language is a set of markup tags which describe document content. HTML documents contain HTML tags and plain text, where documents are also called web pages. HTML describes the structure of a page. HTML, by virtue of its HTML heritage, is a language for describing the structure of a document, not its actual presentation. The idea here is that most documents have common elements, for example, titles, paragraphs, and lists. Before start writing, user can identify and define the set of elements in that document and give them appropriate names.